Every single day, there's this invisible shield that's protecting you from all the electricity that powers our world. But how do we actually know that shield is going to hold? Well, today, we're going to meet the two critical guardians of electrical safety, the insulation resistance test and the Hipot test. A better way to think of them? A doctor and a drill sergeant for your electronics.
I mean, really think about it for a second. We're just surrounded by all this high-powered stuff. Your phone charger, your car, the machinery at work. How are we so sure that all that electricity is going to stay where it's supposed to? What actually gives us that trust?
Well, the hero of the story is insulation. It's the barrier that sits between the live electrical parts and, well, everything else. But just having it there isn't quite good enough. We have to know it's doing its job. And that is exactly where our two main characters for today's explainer come into play.
So, let's get right to it. Let's meet the two methods that are responsible for making sure this critical safety barrier is up to snuff. One of them carries a stethoscope, the other carries a megaphone, but they're both on the same team trying to keep us safe. Okay, first up, we've got the insulation resistance test, or just the IR test. You should think of this one like a health checkup. It's not trying to push the insulation to its breaking point. Instead, it just applies a steady, pretty low DC voltage to measure the quality of the insulation. It gives you an actual number, a value in megaohms. What it's really looking for is slow decay, maybe a little moisture, or some contamination. And then we have the high potential test, but pretty much everyone calls it the Hipot test. Now, this is not a checkup. This is a full-on stress test. It cranks up a really high voltage, way, way beyond what it would normally see, to find out if the insulation can take a punch. It's not looking for a number, it's looking for a very simple answer. Does it hold or does it break? It's pass or fail. That's it.
And this, right here, is the absolute best way to think about them. The IR test, that's the doctor. It's doing a routine, non-invasive checkup to see how things are going, monitoring the long-term health of your equipment. But the Hipot test? Oh, that's the drill sergeant, screaming, "Are you tough enough?" It is a high-stress boot camp designed to prove, with zero doubt, that a component is fit for duty.
So now that we've met our doctor and our drill sergeant, let's put them side by side and really dig into how their methods, their goals, and their whole approach are just fundamentally different. So the most important thing to get is their core mission. The doctor, the IR test, its whole goal is about health. It's looking for signs of slow aging, like moisture creeping in over the years, or dirt building up. It is all about preventive care. The drill sergeant, though, is all about strength. The Hipot test is actively trying to find one single point of failure, a tiny nick in a wire, a defect from the factory, or spacing that's just a little too close that could cause a total breakdown under pressure. And this leads to a huge difference in their impact. The IR test is non-destructive. A healthy piece of equipment will pass the doctor's exam and be completely fine. The Hipot test, on the other hand, is potentially destructive. If there is a weakness, the drill sergeant will find it by making it fail right then and there. And look, that's not a bug, that is the entire point. You want that failure to happen in a controlled test environment, not out in the real world. This table really lays it all out. Just look at the voltage. The IR test is down here, using maybe a few thousand volts, while the Hipot test is way up there. It's a huge difference. Then look at what they measure. The IR test gives you a resistance value, a specific health metric, kind of like a blood pressure reading. The Hipot test, it's just measuring leakage current to give you that simple verdict, fit for duty or not. So you see, you use them at totally different times for totally different reasons.
So where do our doctor and our drill surgeon actually do their work? Let's take a look at how these tests get applied from the day a product is born on the factory floor to years later when it's out in the field.
Okay, here's the doctor's procedure. It's very methodical, very safe. First, you make sure the equipment is totally off and disconnected. Then you hook up the tester, apply a steady voltage for about a minute, and then you just write down the resistance. It's a calm, careful, data-gathering process. So where does the doctor make his rounds? Out in the field. IR testing is the go-to for routine maintenance on motors and transformers that are already in service. It's for checking up on cables that have been buried for years, and for inspecting equipment for any contamination. It's all about maintaining health over a long period of time. And now, the drill sergeant's trial. The Hipot test is, well, it's a lot more intense. You hook up the high voltage, and then you start ramping it up, slowly but surely, to a really stressful level. You hold it there for a minute,
and watch the leakage current like a hawk. If that current suddenly spikes, boom, the recruit has failed the drill. If it holds steady, it passes inspection.
And the drill sergeant's territory? That's the factory floor and the acceptance lab. The Hipot test is absolutely essential for that final test on the production line for a new washing machine or a new power tool. It's required for regulatory bodies like UL and IEC. It's basically the final gatekeeper that decides if a brand new product is safe enough to even leave the factory.
So after seeing them side by side, you might be asking yourself, all right, so which one is actually better? But see, that's really the wrong question to be asking. Let's bring all this together. Here's the most important thing to remember. They are not competitors. They are partners. They work together as a team to guarantee safety across the entire life of a product. You really can't have a truly robust safety program with just one of them.
I mean, it's just a perfect partnership, right? You need the drill sergeant to certify that a product is built correctly and is safe to go out the door. But then you need the doctor to come in and perform those regular checkups throughout its life, just to make sure it stays safe as it gets older and deals with wear and tear. And that really just leaves us with this one last thought. When you're talking about the lifelong safety of any electrical system, what's more important? The constant, gentle monitoring of its health, or the occasional, intense proof of its strength? The answer, as we've seen, is that you absolutely, without a doubt, need both.